Welcome to physics class on motion in a plane part 2, and I will try to make this video if it possible for the whole length, but if it is not possible then I will make it again into different parts. Now let's see some of the topics that we are going to discuss today. The first one is vector addition, then unit vectors, then lastly we will try to see about the scalar and vector products. So first let's try to do about the vector addition. And in the first part I told you that we have already discussed that vector cannot be added algebraically, rather vector are added geometrically, that means by geometrical methods. So vector are added geometrically, okay, that means vector addition can be done by geometrical methods. Now the first law that is coming in the addition of vector is triangle law. What does this triangle law of vector addition states? If two sides of a triangle, okay, if any two sides of a triangle completely represent two vectors both in magnitude and direction taken in the same order, then the third side taken in opposite order represents the resultant of the two vectors both in magnitude and direction. What is meant by this taken in order and taken in opposite order? Let me tell you, okay. First, suppose a vector is represented just like this with an arrowhead. So let's take it that this is a vector, and if another vector starts from this vector, the head of this vector I mean, now we call it the initial point, this point as tail of the vector or the initial point, and this head of the arrow, this point, we call it this point as either head or terminal point of the vector. So from the head, or rather the terminal point, if another vector starts, okay, from here, that means if the head of one vector is the starting or the initial point of another vector, then we call it that two vectors taken in order, okay, like this. So one vector, a vector, starts from here, and another second vector starts from here like this. So this is B. So these two vectors are said to be taken in order, that means one after the another, okay. These two vectors, okay, if these two vectors A and B vector, if it can represent two sides of a triangle, okay, both in magnitude and direction taken in order, then the third side or the closing side of these, okay, would be triangle. That means this will be the third side, right? If these two vectors represents the two sides of a triangle, then the third side or the closing side of the triangle taken in opposite order. If I take it like this, then it will come like this in the order, okay, but you have to take it in the opposite order. So what happened, your opposite order will be along, your opposite order will be along this, in this direction. So these third side or the closing side taken in the opposite order, that will represent the resultant of these two vector, a vector and b vector, and we will represent these resultant vector as r vector, which will be equal to what, a vector plus b vector, like this. Got it? That is nothing but this is the triangle law of vector addition. So let me state it again. If two sides of a triangle completely represents the two vectors both in magnitude and direction taken in the same order, then the third side, okay, taken in opposite order, will represent the resultant vector of the two vectors both in magnitude and direction. Now see, I am giving you one example, okay. Let's take it in the actual way. Suppose you are trying to move, okay, by aeroplane from Egypt to Yemen, okay, and then to from Yemen to Iran. Then we may take it that the first part, okay, the first part that moves from Egypt to Yemen, let's take it that as a vector, okay. The direction is from Egypt to Yemen, right? That will represent a vector. And the part that is moved from Yemen to Iran, let's take it that as b vector. Then the resultant will be what? It will be from resultant, the resultant vector will be from Egypt to Iran. Got it? From Egypt to Iran, and that will represent what? A vector plus b vector. Got it? So the sum of these two vector, a vector and b vector, will be equal to r vector, and that r vector, that is nothing but a vector plus b vector, will be from Egypt to Iran. Got it? It is same thing given here. If that r vector, in this case it is represented by the c vector, okay, from Egypt to Iran. Got it? Yes. Now parallelogram law of vector addition. There are three laws, okay, and these three laws are almost same in one way or the other. The first law is triangle law of vector addition. The second law is parallelogram law of vector addition, and the third one is polygon law of vector addition. What I said that these three laws are more or less the same means what? The three laws, okay, it is different in their in their statement and uses only, but one can be deduced from the other. That means you can derive one of these law from the other two laws also, okay. So any law out of these three laws, any one law, okay, if you take it out of these three laws, then you can derive it from the others also. That's why I said that these three laws are more or less almost the same, okay. Let's see about the parallelogram law of vector additions. If two vectors, okay, represented both in magnitude and direction, this word both magnitude and direction is very important, okay. This word both in magnitude and direction, okay. If you are going to represent that vector by another vector which is equal, then it should be equal both in magnitude as well as direction, okay. If one vector is like this, another vector is slanting like this, if both of these vectors, okay, if they are of equal magnitude but directions are different, so these two vectors can never be equal. Got it? Why? Because magnitude may be same, equal, but directions are not same, okay. Directions are different, so we can't take it that these two vectors are equal vectors. Let me erase it all, okay. So now let's see. Yes, the parallelogram law of vector additions. If two vectors, okay, represented both in magnitude and direction by the two adjacent sides of the parallelogram taken in order, okay. In the case of triangle law of vector addition, it was taken in order, but here it is not like that. The adjacent sides, if two adjacent sides, okay, like this, these are the two adjacent sides, so these two adjacent sides cannot be taken in order, but it should start from the same point, okay. It should start from the same point. Then what does this parallelogram law states? That what states? This parallelogram law of vector addition states that if two vectors, okay, let's take it as a vector and b vector, if they represent the two adjacent sides of a parallelogram, okay, drawn from the same point, that same point is this point, okay, from the same point, then the resultant vector is represented both in magnitude and direction by the diagonal of the parallelogram passing through the same point or drawn from the same point. That means if these two vectors, a vector and b vector, if it is represented by the two adjacent sides of a parallelogram taken or drawn from the same point, then if you try to complete this parallelogram, okay, then the diagonal that is drawn from that same point, that diagonal will represent the resultant vector of these two vectors, a vector and b vector. So your resultant is this one. So as I have represented by r, your resultant vector will be equal to r, and this will be represented again similar to that previous one. It will be a vector plus b vector, like this. Now, as I told you that the triangle law and parallelogram law of vector addition are almost same. Now, instead of stating that two vectors represented by the two adjacent sides of a parallelogram both in magnitude and direction, instead of that, you try to take this b vector, okay, here, like this here, because these two are having of same magnitude, because they are the opposite sides of a parallelogram, and rather parallelogram means they are parallel, the direction also same now. So instead of this b here, you take it out here, b vector, then it will be just like that of the triangle law of vector addition, right? If two vectors, if it can be represented by the two sides of a triangle both in magnitude and direction taken in order, then the closing side or the third side taken in opposite order will represent the resultant of these two vectors both in magnitude and direction, right? That is what vector law of triangle addition, right? So your parallelogram law and vector triangle law are almost same. That is what I said, right? See, this is a picture that can be shown here in relation to this parallelogram law of vector addition. Now you may take it that here is a lot, okay, and this is a frictionless pulley, okay, and by means of a two string, okay, you are pulling down this lot through like this. So a is a vector that is pulling downward, okay. Now you may take it this a vector as the force, okay, this b vector also another force. So that much force that is pulling down like this, that much force will be also on this string. That much force that is pulling, okay, by this a vector, let it represent a vector represent another force. So that force that is pulling downward must be also here, okay, that force. So your a vector and b vector, okay, are as if they are pulling like this. So the resultant of these two, what happen if you try to complete the parallelogram, then what happen, the resultant will be along the diagonal passing through this same point. So this block of mass, okay, if these two forces a and b, if they are pulling downward, then what happen, the two force are acting as if one here another here. So what happened, the resultant of these two force a vector and b vector onto this block of mass, the block of mass will be moving along this. That means this is the resultant direction. Got it? If these two a vector and b vector are same, then it will move along the middle part in between a vector and b vector, in between these two parts, that means here in the middle. But if a is somewhat greater, if a is greater than, if I mean a vector is greater than b vector, then the part of this block of mass will be closer toward the what, a vector, that means bigger vector. Got it? How it happens? Now if you can draw that parallelogram like this one is longer means of larger magnitude, and b is of smaller one, like this b vector. Then if you try to complete the parallelogram, then it would have been like this, and the resultant will be toward the bigger vector c. So if a vector is greater than b vector, b is small, represented by a small magnitude, longer length means what, of greater magnitude, okay. If you try to draw the diagonal, then the diagonal is moving toward the what, bigger magnitude vector, right? Same thing is the case, okay, in the case of parallelogram law of vector, it is like that, right? Now let's try to see about the other law that is known as polygon law of vector additions. So if a number of vector, okay, if a number of vectors are represented both in magnitude and direction, this word both magnitude and direction are very important, okay. If a number of vectors are represented both in magnitude and direction by the two sides, by the sides of a polygon. In the case of polygon, there will not be not only two sides, but it will be more than two sides, okay. If a number of vectors are represented both in magnitude and direction by the sides of a polygon taken in the same order, then the resultant vector is represented both in magnitude and direction by the closing sides of the polygon taken in opposite order. Now I will give you that figure to represent or to clarify this law by means of diagram, okay. Now let's take it that there are some, say, four vectors. One vector here, a vector, okay, a vector that is represented by this red line, a vector, okay, with this line. Then another b vector, c vector, d vector. They are all in what? Different directions, okay. So if you want to take it this a vector and represent it somewhere here, then you need to take it of the same magnitude and same direction, okay. We call it these as free vectors, okay, that can be shifted, okay. This a vector can be shifted somewhere here, okay, with the same magnitude, same direction. That means direction must be parallel, okay, and of same magnitude. You need to take it this much length, here also that much length, got it. And this b vector here with the blue line here, this blue line, okay, it is acting along this, so you take it taken in order. That means one after the another, okay. The head of the first vector, a vector, will be the starting or the initial point of this second vector. Can you get my point? The head or the terminal, okay, of the first vector will be the initial point for the second vector. So like that, the vector is along this, like this b vector, and this b vector, the head of this b vector will be the starting point or the initial point of the third vector. So it will be like this. So this magnitude and direction must be same. This direction c vector, okay, its direction is along like this, downward little bit, so it will be in this way of same magnitude. And the fourth vector, you keep on continuing like this. So these four vector, a vector, b vector, c vector, d vector, like this, they are all taken in order, okay. So these two or more vectors, if it can represent the sides of a polygon, okay, both in magnitude and direction and taken in order, then the closing side of that polygon, okay, will represent both in magnitude and direction the resultant of all those two or more vectors taken in opposite order, okay. So this is the polygon, okay. And if we complete this polygon, then the closing side, that will be this side. And if I take it like this, then it will be taken in order again, but it's not be taken in order, rather it should be taken in opposite order. So if I take it that this is the third side, or I mean the closing side, not the third side, the closing side, and if I take it that closing side taken in opposite order, then this closing side taken in opposite order will represent the resultant of all those four vectors, a vector, b vector, c vector, and d vector, like that. So your e vector can be represented by what? A vector plus b vector plus c vector plus d vector, like that. Got it? So now, as I told you that these vector additions like that of triangle law, parallelogram law, polygon law, I told you that these are almost same, no? So if you take it that these two vector first, a vector and v vector first, the resultant will be represented by this line, okay. If you take it these as a two sides of a triangle, then the closing side will be this one, right? So it will represent what? Your a vector plus b vector, am I right? So instead of this a vector and v vector, let me represent it by a vector plus b vector, okay, because this is a resultant. Resultant means any vector which can replace, okay, that two vector, we call it as resultant of that two vector. Got it? So a vector plus b vector will represent what? Your resultant vector. So instead of these two, so let's remove it, these two, and let me represent it here, the two vector as a plus b vector here, like this. Now you think that one vector is here which is equal to a plus b, another vector c, so they are taken in order, okay. So these two, again we can represent it by using your triangle law of vector addition. The resultant of these two vector a plus b plus c, that will be represented by this line. Am I right? So this line will represent what? Your a vector plus b vector plus c vector, right? So again, if you take it, this a plus b plus c vector with this d vector taken in order, right? Then the third side means this side, right, taken in opposite order. So this will represent again what? A plus b plus what? C. A plus b vector plus c vector plus d vector, right? So this resultant will represent what? A plus b plus c plus d vector. That means your parallelogram law, or rather your polygon law of vector addition, I told you that they are more or less the same. That proves what? They are same. This proves that your three laws are almost same, right? Now let's see about some properties of vector addition. Vector addition is commutative. That means vector addition is commutative means what? The order can be, okay, changed. A plus b vector will be equal to b plus a vector, okay, like that. A plus b vector, a is here with the red line. So this is your a vector and this is your b vector. So instead of taking a plus b, you can take it also as b plus a. First you take it b vector and then you add a vector like this, okay. First here a plus b vector means after a, b comes, okay. But here what happened? After b it comes a. So both the resultant c vector will have the same magnitude, will be also same, direction will be also same. So that shows that what happened? Order can be changed. First you write it here, second you write it here. So this order can be changed. That means your second vector b can be written first and then a can be what? Written in the second. So this shows that your vector addition is what? Commutative. Now let's see about vector addition is what? Associative. Associative means whichever you associate first, okay. Let's take it here. Here a plus b, okay. A plus b is what? The first two vector, addition of the first two vector, and then you add it the third one. So first you add it the first two vector and then you add it the second one. Instead of that, you can add the last two and then you can add to the first. The result will be same. It can be seen here a plus b. If you edit this first, okay, and then later on you edit this third one, the resultant will be same d1, okay, this d vector. If you edit this first two, then the resultant of a plus b will be represented by this, and then you can take it these two as a vector addition, triangle law of vector addition, then the resultant will be this one, right? Same thing here also. You first add this b and c first, the resultant will be this one, like this, right? So if you add these two again, then you will get this d vector. So the result is same. So that means what? Your vector addition is what? Associative. Let's see about the vector addition of distributive in nature or not. Yes, vector addition is distributive, okay. So now if you take it that a plus b with the two vectors, okay, let's take it any two vector a and b here. So your vector a, okay, and b, okay, let's take it that a is like this, b is in this way. What does it represent? This is a vector and this is b vector, okay. And if you edit these two, then the resultant will be this one, right? So let's represent this A plus B by the resultant R. Now instead of this, if you are taking that this, what is this n? This n is any real number, okay? So let's take it this real number as 2, for example, just to prove you, okay? Let's take it that n is equal to 2. So n is equal to 2 means what? It represents that this n times a means what? It will be twice a. Your b will be also what? Twice b, like this. Then let's check it that whether if you use it this a 2 times, 1 a, this much, another a again, so this much is twice a. So let's take it that this is twice a vector. Got it? And if you use it this b vector 2 times, like this, 2 times, okay, I cannot draw it, so let me draw it again, okay? Let me move little bit toward the left side so that I can draw it, okay? So let's take it that this is what? Your a vector. First a vector of this much length, then second vector this much of another a, so that a plus a, it will be twice a. Let's take it that this is twice a. And let's take it b also twice b. So one b here, this much length, another b, this much. So the whole length will be of twice b, right? So this will represent what? Twice b, right? And what happened? The resultant of these two vectors, twice a plus twice b, taken in order. So by using your triangle law of vector addition, this will represent the resultant, okay? The resultant of what? Twice a vector plus twice b vector, like this, right? So this length, okay, this is nothing but this will be equal to 2 times of this r vector. So this is of r, so one r here, this much length, another r here, so this will be surely of twice r vector. That means twice r means what? 2 times of a plus b vector. So your r is nothing but this is of a plus b vector, right? So that shows what? Your triangle law, your addition of vector, what? Holds for associative. That means your triangle law, your addition of vector is associative in nature. Got it? So your vector addition, that means it will be of distributive in nature, not associative. Associative was that of the previous one, because this n, okay, the real number, it need to be what? Distributive. If it doesn't hold good about distribution, then it will not be equal to n times of a plus b, will not be equal to n times a plus n times b. This real number can be distributed, okay, to each of this vector. So that shows what? Your vector addition is what? Distributive in nature. Subtraction of vector. Actually, in the case of vector, there is no such subtraction of vector. Rather, it is addition of vector with the opposite, okay, with the opposite of the another vector. I will tell you all about this when we go further, okay? Now let's take it that a and b here. A vector is represented by the red color line, and b is represented by this blue color line. So a is represented by this vector, red color, and b vector is represented by this blue color line, okay? A plus b, we know it from that triangle law of vector addition that this will represent the resultant, or rather a plus b vector. But if I am going to take it that a minus b, then how it will be done? That is a question, okay? Now this is b vector. We know that if a vector is given like this as b vector, okay, and if you want to do it that negative, if you want to take it negative of this given vector b, then I have to take it of the same length, okay, and the direction, if it is opposite, then this will represent the negative of that given vector b. Got it? Equal in magnitude, opposite in direction, we call it that as negative of the given vector, right? Same thing is also here. A is with the red color like this, and b would have been in this direction, right? B would be in this direction. b vector I mean. So the negative of b vector means it will have to be taken in the opposite order but of the same magnitude. Am I right? So then your b vector will be what negative of b vector I mean will be along this line in this way. So if you add these two, okay, now forget about that of minus b and all. You just take it that these two triangles, okay, the sides of these two triangle which will represent one vector and another vector minus b taken in opposite order. Then by applying your triangle law of vector addition, if these two sides of a triangle taken in opposite order can represent both in magnitude and direction the two vectors, okay, a vector and b minus b vector, then the resultant of these two, a vector and minus b vector, will be represented by the third side, okay, taken in opposite order both in magnitude and direction, right? So this is nothing but this is rather the addition of two vectors. That means a vector plus of minus b vector. Got it? So that is what it is written here. So rather I told you that there is no such subtraction of vector, rather this is what addition of a vector with the opposite of another vector, right? So that is all about your vector addition and subtraction. Now this is just the repetition of that previous one, okay? Law of vector additions. If two sides of a triangle completely represents two vector both in magnitude and direction taken in order, then the third side taken in opposite order represent the resultant of the two vector both in magnitude and direction. That is what we have already done. But in order to prove this, okay, that this the third side taken in opposite order will represent the sum of the other two, we are going to prove it that one, okay? So now let's take it that p vector is the vector which will be represented by the line segment OA from O to A. Okay, the direction is from O to A. This is known as P vector. Let's take it. And another vector Q vector, okay, from O to B. Now this is for triangle law vector addition. So instead of that that vector OB vector which will represent Q vector, we can take it here, right? So that means these two are taken in opposite order, then the resultant will be represented by this third side taken in opposite order, right? The angle between these two vector P vector and Q vector, P vector can be taken along like this, okay, and another vector here, so angle between them will be theta. So you can take it here also, that angle theta here like this also. Got it? So if they can represent, okay, the two sides of the triangle taken in opposite order, then the third side will represent the closing the third side or the closing side will represent the resultant vector of these P vector and Q vector, right? So by completing the triangle, okay, by completing the triangle, you can complete this triangle, okay, first like this, the first vector, second vector like this, the third side will be like this. So after completing this triangle, then you try to drop down from this point C perpendicular to that OA produce, okay, OA produce, you elongated OA produce so as to meet at this point M. That means this angle is perpendicular. So we are having a right triangle here, as triangle AMC is a right triangle, and at the same time triangle OMC is also a right triangle, okay? So whenever required we will use this triangle AMC, okay? So cosine of theta, we will use that from this triangle AMC. Cosine of theta will be equal to what? Base by what? Hypotenuse, okay? Base is how much? Base is AM, okay? Hypotenuse is what? AC. And sine of theta is what? Perpendicular by hypotenuse, right? Perpendicular is what? CM or MC, you can write CM divided by AC. So what is this AC? AC is nothing but this is a magnitude of that Q vector, okay? So this is nothing but this will be the magnitude of Q vector, right? So we can replace it by that. And whenever required, this am, so from this first equation of cosine theta, am can be written as what? Q, magnitude of Q, we can write it like this, magnitude of Q vector times what? Cosine of theta. So Q times cosine of theta can be expressed as what? Am, right? Cosine of theta can be expressed as what? Am. So whenever required, we will use this one also. Likewise, when we require this Cm, we can express as Q times of what? Q, if you transfer this Q to the right hand side, then it will be Q times of sine theta. So this can be used. Got it? So it will be coming up here in the latter part. Let's see. Let me first erase it out all and I will show you one by one. Okay. Now in triangle OCM, okay, in triangle OCM, that means this bigger triangle, okay. So this bigger triangle OCM means this one, right? So your OM will be equal to what? OA plus AM. So there we will use that AM in terms of that of what? Cosine of that theta. Okay, Q times of cosine of theta we will use there. So whenever this CM is coming, then we will use that of Q times of sine theta, right? So from this right triangle, we know that square of the hypotenuse will be equal to sum of the square of the remaining two sides by using your Pythagoras theorem. Okay, so OCM square will be equal to what? OM plus CM square. So OC square will be equal to what? OA plus AM plus CM square, right? So OC square will be equal to what? OA square, if you open this bracket, okay, OA plus AB whole square. So you use it, that formula, A plus B whole square, and if you expand it, then it will be coming like this, right? Then what happened? AM square, then plus CM square. So in the next part we will use it, that one AM will be equal to what? Your AM is nothing but it will be equal to Q times of what? This sine theta, I mean cosine of theta, right? Cosine of theta. And your CM will be equal to what? Q times of what? Sine theta. So we will use it, this AM and CM here, AM and CM here. Got it? And let's see what will be obtained in the next part. This was the same diagram. Okay, just I'm redrawing it. That is what I have said. Instead of that of AM, you use it as what? AC cosine of theta. AC will be nothing but this will be, AC will be nothing but it will be what? Magnitude of the other vector Q. That is what I'm using here. Okay, so after doing that simplification, you will get it that the resultant, okay, this, I think one is missing here, R square is missing, right? So your R will be equal to what? Square root of this remaining thing. That is what it is given here. So your resultant vector R will be equal to what? Your R will be equal to, I mean your R vector will be, now this is only the magnitude, okay, magnitude of R vector will be equal to your R, I mean P square, I should write it as P square plus Q square plus twice PQ cosine of the angle between them, and you take it the square root of this. So this will give you the resultant of this, I mean the magnitude of the resultant of the two vectors. Okay, and the next one, just to find it out, the direction of the resultant vector, you can use it, this still, this what right triangle here, and just to find it out that I'm sorry, not here, here I should say, here from this right triangle, you try to take it the angle between the resultant vector and P vector, if that is denoted by alpha, then tangent of alpha, if you take it that tangent of alpha, then it will be what? Perpendicular by base. Perpendicular is what? CM. Base is what? OM, right? So your CM is what? CM is nothing but this will be Q sine of theta. We have done that one, okay? And OM is nothing but it will be equal to OA plus AM. OA is what? This is a magnitude of P vector. OA means this one. And AM is nothing but this is a base, so it will be cosine, Q cosine of theta. This also we have done, right? So your alpha can be expressed as what? Tangent inverse. What is this alpha? Alpha is the angle between the resultant vector and the P vector, okay? So it will be equal to Q sine of theta divided by P plus Q cosine of theta. So this will give you the direction of the resultant vector with respect to this first vector P. Got it? So it will be just seen here in the next slide. See here. So your tangent inverse, okay, if you want to take it this tangent inverse of the last expression, then it can be written in this way. See, tangent inverse is equal to Q sine theta divided by P plus Q cosine of theta. Got it? And with this we come to the end of our today's class. Thank you for watching my video.